Hi, AP Pre-Calc students. It's Miss Adams from Flamingo Math. We're in our last day on lesson 13 in chapter 4, talking about matrices as functions. And in this lesson, we're going to finally look at all the possibilities of how two linear transformations could have an inverse. Remember, we have said that a function has an inverse that we call f inverse, and these two functions undo each other. Formally, we said the f of f inverse of x is the identity x, and the f inverse of the f of x is the identity x for all values of x in the domain of f. This is also the range of the inverse. We can do the same thing for linear transformations of matrices. Our definition for an inverse of a linear transformation is stated here. If we have a dimension of r to the n mapping to r to the n, if that's a linear transformation defined by some matrix A times vector x, then T is invertible if and only if A is invertible. So our matrix A has to be invertible, and T is invertible. Its standard matrix is A inverse. So using those properties, let's try a few examples. Describe the inverse of the following transformations in the plane. A rotation of pi over 6 counterclockwise. Well, we could say the inverse would be a rotation of pi over 6 clockwise. We could also say that it could be 11 pi over 6 if we went counterclockwise. So just going the opposite direction. A horizontal contraction of k equals 1/4. Well, we could have a horizontal dilation if we had k being 4. I'm going to call it k prime to be 4. A reflection across the line y equals 2x. We could have a transformation if we had a reflection across the line y equals 2x. It would be the same thing. Example 10. Let t go from R2 to R2, be a dilation by a factor of 3. That is that t of x is 3 times x. If t is invertible, we want to find t inverse. So that's telling us that our A matrix is 3, 0, 0, 3, because we have that dilation on the identity matrix. The determinant of A is 3 times 3 minus 0, so the determinant is 9. The inverse is 1 over 9, 3, 0, 0, 3. So T inverse of x is 1/3, 0, 0, 1/3 times x bar. This is a contraction by a third if you want to write that down, just for your reference. This is a contraction or a shrink by a factor of 1/3. So our model said this is A and this is X. Example 11. Let T equals, we got two example 10s. Let's go on to 11. Let T map R2 to R2 be a reflection over the y-axis. I'm going to highlight that. We have a reflection over the y-axis. Is T of x invertible? If it is, find T inverse. So we want to make a little sketch of what's going on here. Let's see. T of x has to be A times x, and A is -1, 0, 0, 1. So this is how we get the reflection over the y-axis. We've seen that before. And let's just suppose we have some vector over here at 2, 1, just for an example. If we have a reflection over the y-axis, our reflection has to move it to the vector -2, 1 in order to make that be reflected over y. So the determinant, let's think about the determinant of A, is -1 minus 0. So the determinant is -1. And T inverse needs to undo T. So A inverse of X is going to be -1, 0, 0, 1. And T inverse equals T. So the reflection will undo itself. And that followed what we learned in a previous lesson, where if we just replace this with the opposite, we would have that reflection and keep the y value. And that's what our inverse matrix does. So we know that they are invertible and that the T inverse is itself. Example 12, we want to find the inverse of the linear transformation if it exists and write it in the same form. So they're giving us, let's go to the highlighter, write it in the same form, and they're giving us this transformation. If we write that in a matrix, we got T of X, Y, Z, so 3 rows, 1 column, has to give us Y plus 2Z, X plus Y plus Z, and then 3Z minus X for our column matrix. So I could use a calculator. I'm not going to take the calculator out, but I'm going to make note that I'm going to use a calculator to find A inverse. So T inverse of X bar is going to be A inverse of vector X. So T inverse of X bar is 0, 1, 2, 1, 1, 1, -1, 0, 3. And I'm taking that from this information back here. X is 0, Y is 1, Z is 2, X is 1, Y is 1, Z is 1. X is -1, there's no Y, and Z is 3. This is my A matrix, and I've got to multiply it by my X bar, and X bar is X, Y, Z. So the inverse that my calculator has given us is 1 over 2, -3, 3, 1, 4, -2, -2, -1, 1, and 1. And they want us to write that in the same form that we were given. Oh, I'm out of space here. Hold on just a minute. We need more space. Okay, I have our inverse moved up here, and we want to write in the same form we were given here. So we're going to write this in the same format. We have to pull 1/2, and then we've got -3x plus 3y plus z off of the top row. The second row is 4x minus 2y minus 2z for the second row. And finally, -x plus y plus z off of the third row. This is our transformation inverse on x, y, z in the same format that we were just given. And finally, in this lesson, for example 13, we want to find the transformation inverse for the linear transformation given here, t of ax squared plus bx plus c. So we want to do t inverse of t ax squared plus bx plus c. That has to be equivalent to the inverse, not negative inverse, to the inverse of a plus c, 2b, a minus c. So I like to write it as matrices. Ax squared plus bx plus c has to be our a, b, c vector. And we have our a vector times x bar has to be the transformation. So a times x bar. The a would be 1, 0, 1. A is 1, C is 1, there's no B. Then in the middle we have 0, 2 for B, no C, 1A, no B, and a negative 1 for C, multiplying by our A, B, C. So using matrix operations, A plus C is row 1, 2B is row 2, and A minus C is row 3. So we took that from the given information there. Now finding the inverse, A inverse, and again I'm going to use my calculator to do this for me. 1/2, 0, 1/2, 0, 1/2, 0, 1/2, 0, negative 1/2. We can pull the 1/2 out so that we have all ones and zeros. 1, 0, 1, 0, 1, 0, 1, 0, negative 1 times our ABC. That gives us the transformation. Whoa, what happened here? So this means our transformation, T inverse, has mapped from R3 to P sub 2, I'm sorry, because we did the directions said. We were given where T was P sub 2 mapping to R3, so we're doing the opposite. We're mapping R3 back to P sub 2. Our T inverse on ABC is 1/2, and I'm doing this here, A plus C, 1B, and then A minus C. This is our T inverse. And that, my friends, is the end of lesson 13. We have 3 more lessons for lesson 14, and we will be finished with a full year of AP pre-calculus.